Hi, I'm Ansh Chandarana, registration number 19 BCE 0112. I study at VIT, that is Vellore Institute of Technology, and this video is part of an theory assignment given by our professor Anuradha Ji, and it is about unicasting and selective repeat implementation by socket programming in Python. So first of all, we'll understand what exactly unicast means. Unicast transmission is a one-to-one communication that passes from a single source to a single receiver or destination. One of the simplest everyday examples of unicast transmission would be a phone call between two people. In computing terms, unicast transmission is the most common method of information transfer which takes place on networks. Traffic in the form of streams of data packets typically moves from a single host, such as a web server, to a single endpoint, such as a client app or a browser or a computer. Though unicast transmission is point to point, the same information may be passed from source node to any other number of nodes on a network. But the key point here is send all it cannot send the same information to all the nodes at the same time. It has to do so in a succession of one-to-one communication. A replica of each packet in the data stream goes to every host on the network that requests it. More technically, unicast transmission employs Internet Protocol or IP provision techniques such as Transmission Control Protocol (TCP) or User Datagram Protocol, that is UDP. These are the session-based protocols which allow communication to be set up, completed, and terminated as a single operation. A unicast transmission is sent to a single node on the network, which is identified by a unique 64-bit address. The next thing is socket programming. What is socket programming? It is a way of connecting two nodes on a network to communicate with each other. Simple, like one node listens to a particular port at an IP. Here we have the server side program that listens on the specific port, and while the other socket reaches out to the first one to form a connection. Here the other node, the second node, is the client side. So another important concept to discuss here is selective repeat ARQ protocol. It comes into action when the data that is sent between these two nodes isn't correctly received by the receiver. And what it basically says is whenever there is an erroneous frame or some frames are lost, uh, then those and only those frames are to be retransmitted, while the frames that have been correctly received are buffered. So the receiver, while keeping track of the sequence number, buffers the frames in memory and sends a negative acknowledgement for the frame which is missing or damaged. So now I'll explain the code. So here it's a server side program and this is the client side program. As you can see, there are some things common like n is 4 and port is 12344, uh, and here n is the window size. In the selective repeat protocol, the sender can max send the at max at a single point of time can maximum send n data frames to the server or the receiver. So here n is 4, so it can send 4 data frames at a time at maximum. Here we are using the host name of this PC. So we're using the get hostname function. As you can see, it is in both the programs. Why we're doing this is because both of these codes are being run on the same PC. If there is a possibility where there are more than there is two different nodes, like they have different IP addresses, that is possible in Unicast. But since we are using both of this code, we are running both of this code on the same PC. We are using the get hostname method. We also use variable like window start and window end, and yes, yeah, here the socket initializes the server socket as well as the client socket. As you can see, it just initializes the socket. Now is the most important part of the code. Here the dot bind function takes tuple of host and port that we above saw, and it initializes a connection, and it uses the dot listen method to actually start listening for any client that wants to connect to it and share information. So as you can see here, we have the dot connect method from the client program that we use to connect. Here the important part to note is the port should be similar. In order to connect, the host might be different, but the port should be similar for the server and client to connect. And the rest of the code is just a basic selective repeat that I explained to you how they send the negative acknowledgements. And another thing to note here is the 1024. This says that at whenever a data frame is sent, that is, the data frame size is 1024 bytes. You can see here also we are receiving and sending 1024 bytes. So let's see the code in action. Remember, first we always have to set up the server side program. We have to run the server side program. So it will first get run and it will start listening. Now we'll run the client side program. As you can see, the connection is successfully established. This is the client side window. I'll just expand it. So here it says the window size is 4 as I explained earlier, and this server side output shows that there is a connection established at this IP address, and you can also read that it says whenever that I enter by, it will close the connection. So let's just enter anything random. Let's see what happens. So here we see the 4 frames are being sent. These 4 frames are in the window at first. So these 4 are sent by the client. Now as we can see, only the frame 1 and 0 are being received at the server end, and it sends a negative acknowledgement that you still have to it sends a negative acknowledgement to client that you still have to send me the frame 2. So whenever we click enter, it will send the frame 2, and now the only frame left in the window is 3. So it will send the negative acknowledgement for 3. Now we have to note here that at a time the server can only send one negative acknowledgement, so the client can also only send the one frame if there is a negative acknowledgement. But if the negative acknowledgement is for a frame that has yet to be sent or that is not in the current window, then the client knows that all the data frames that are sent were sent successfully, and now it can slide down and send the next frames in the window. So as you can see, after we click enter here, it will send 3, and now the window is empty. So it's asking for the client side, the server side is asking for 4 data frame 4. So now the client side knows that there is nothing left in the window. So now it will send the next full window, that is 4, 5, 6, and 7. Let's see what happens. And as you can see, the frame 4, 5, 6, 7 are all at a time sent by the client to the server, and we can see that only 4 is received. So now it's asking for 5, and the next time we enter, it will send 5 and ask for 6. can see similar will happen when 6 is sent, the server side will ask for 7th frame. And as you can again enter, now it will ask for 8, which is not in the window. So the client knows now that it has to send the next full window. So as I'll enter, it will the client will send 8, 9, 10, 11. So let's see. And as you can see, only 11 is received. Is asking for 8. After that it'll ask for 9, and after that it'll ask for 10th. Let's see. So it sent 8, and its server is asking for the ninth frame. And now ninth is sent, and its server is asking for the 10th frame. Now this is the last frame in window. So when the 10th frame is sent, the server asks for the 12th frame, which is not in window. So again, this will happen as the frame is not in the window. The client knows that you have to gather the next window and send all of it to the server side. So this will go on and on. So now we'll just type by and then finish the code. As you can see, the process is finished and with the exit code 0. So here now, if there is another client that wants to connect to the server that has the same port number but a different host ID, can actually connect to the server. But when the server when one client and one server are already connected, there is no way another client can come in and try to connect and share information. Why does this happen? The most important part of the code is the dot listen method. Now this allows, as you can see in the bracket, it's written, I have written as 1. Now this method specifically mentions that at a time only and only one client can connect to this server. So if there is a connection established with the server, there is no way another client can just come in, or there is no way another can just intercept whatever server is sending if it tries, if it has the same if it use the dot connect method with the same post, because there is an already a connection established with the server. So this code proves that this communication is one to one, that is unicast. So that's it. This is how we'll implement the unicasting and the selective repeat protocol with socket programming in Python. And thank you.